Hello everyone. So in this class we will study about electromagnetic waves. So let me summarize what we have done so far in electromagnetism. We did that a charge produces electric field. A magnet produces magnetic field. These were the earliest observations about electrostatics and magnetostatics. Charge produces electric field and magnet produces magnetic field. After it was found that charge in motion, that is current, is also a source of magnetic field. Oersted experiment, which was followed by Ampere's law, Biot-Savart law, that current produces magnetic field. Now, when it was proved that current produces magnetic field, Michael Faraday thought just the opposite, that if current is producing magnetic field, then even the magnetic field should be able to produce electric field or current. So he made his discovery and found, though not the static but the changing magnetic field. They produces electric field or current. Whenever the magnetic flux changes, induced EMF is produced, and if the circuit is closed, a current starts flowing, which he named as induced current. So he found just the reverse of it. Current producing magnetic field and then magnetic field also producing current. Okay, but one important observation was that it is not just the magnetic field. The magnetic field should change. The change in the magnetic field, that is the source of electric field. Maxwell, another eminent physicist, he thought that nature loves symmetry, and we are doing charges, we are doing magnets, and then charges producing magnetic field, magnets producing electric field. So he predicted that if changing magnetic field is a source of electric field, then changing electric field should also be a source of magnetic field. Now listen carefully. Magnetic field can be produced by a magnet, by current. He says no. Just as changing magnetic field is a source of electric field, changing electric field should also be able to produce magnetic field. And so far we have done. So what he predicted, theoretically, changing electric field should also produce magnetic field. This was his prediction, theoretical predictions based on the laws which were already discovered. So he studied B dot dl mu naught I, Ampere's law. This tells us about the magnetic field produced due to current. So he found this law incomplete. So according to him, the source of magnetic field is not just the current. It is also the change in electric flux on the lines of Faraday's laws. E dot dl is minus d phi by dt. He said same way B dot dl should also be equal to d phi E by dt into some constants. Faraday's laws is E dot dl is minus d phi b by dt. Rate of change of magnetic flux produces electric field. So Maxwell also thought that there should be similar law even for magnetic field. There should be some constant into d phi e by dt. This constant to make it dimensionally consistent. Okay, because dimensions of right hand side and left hand side should be same. So he thought exactly of the same type of expression here too. So current produces magnetic field, that's all right. But there should be something else also which also produces magnetic field. And one term should be rate of change of electric flux. So what he did, he added one term into it. Mu naught epsilon naught d phi by dt. And the logic, the reason for using it, just to make it dimensionally consistent. This has the dimensions epsilon naught d phi by dt. This has epsilon dimensions of current. So this can be written as I plus, okay, this term he named as displacement current. Displacement current. So this is how the Ampere's law was modified by Maxwell. So now we can say there are 4 fundamental laws which govern electrodynamics. Gauss's law, the corresponding law for magnetism, Faraday's laws, and modified Ampere's law. All these 4 collectively are called Maxwell's equations. The total electric flux for a closed surface is equal to 1 upon epsilon naught times the total charge enclosed by the surface. Gauss's theorem. There was a corresponding law for magnetism also. The total magnetic flux linked with a closed surface is 0 because magnetic monopoles don't exist. So we don't have this type of term here. Number of magnetic field lines entering any surface always equals to number of magnetic field lines leaving the surface. Because they don't originate or terminate, we have done all it. Okay. Then rate of change of magnetic flux is equal to induced EMF. Faraday's laws. This was given by Faraday. So this is Gauss's law. Then now we have Ampere's law modified by Maxwell's. So Ampere's Maxwell law. Okay. And what is it? B dot dl is equal to mu naught I plus epsilon naught d phi e by dt. These 4 are Maxwell's equations. Though his contribution was this only, addition of epsilon naught d phi by dt to this current, conduction current. But this was not all. He gave these, he collectively, what he did actually, he solved all these 4 equations. Solution means, if we write some value for electric field and magnetic field, it should satisfy all these relations. That's the meaning of solutions. When we find solutions of any equation in x and y, what does it mean? that if we put the values of x and y, it should satisfy those equations. These are the integral equations. Now, if I am talking about the vacuum, so in vacuum Q will be 0 and I will be 0. So Gauss's law, it becomes E dot ds is equal to 0, B dot ds is equal to 0. So we have E dot dl is equal to minus d phi b by dt and B dot dl is equal to mu naught epsilon naught d phi by dt. This is, I am talking about vacuum. Okay, now what are the possible values of E and B which will satisfy these equations? Maxwell did all mathematics and found, he solved these equations actually and found that the value of E. Now I am taking one particular direction. Actually he found that E and B, these two are wave equations. Progressive wave, plane progressive wave. So the expression for E is E naught, I can take sine omega t minus x upon c or omega t minus kx. B is B naught. I have taken the solutions for this when the wave is traveling along x-axis only. So I have confined it to one dimension only. Okay. So in such case, so the solutions are wave equations. But E and B are always found perpendicular to each other and also perpendicular to this direction in which this wave equation is, wave is propagating. So it is moving along x-axis. So it may be along y, z or z, y, both possible. So let me confine myself to x, y and z axis. And I am taking the solution which is E is along y axis. So I can write here this. And B is along Z. So I can write. This is one of the possible solution of this. It can be Z, it can be Y. The idea is that we get the wave equation. And this is traveling with a speed which comes out to be mu naught epsilon naught, and E and B are related by this term, where C is this. So the equations, Maxwell's equations have this solution E and B, they are related together by this expression and C is 1 upon epsilon naught. So these are the wave equations. So what he predicted again, that electric field and magnetic fields as given by these four equations, they are satisfied by this equation. It means he predicted the existence of electromagnetic waves. That electric field and magnetic field are coupled together. It's possible that we have one field producing the other and vice versa. They produce each other and they sustain each other. If we can produce, and this energy propagates onward with this speed. And if we substitute these values, it comes out to be nearly 3 into 10 raised to the power 8 meter per second. Again, this number is very well known to us. It is the speed of light. Actually, after the Maxwell's prediction about electromagnetic waves only, it was found, it was concluded that light is an electromagnetic wave because of this speed. Light's speed was calculated before this also, but by some other methods, and it was exactly same as obtained mathematically by solving these equations. and this is how they are related. So electric field is much stronger than the magnetic field. So this is how electric field and magnetic field are related. But we need, for this to exist, for electromagnetic waves, what do we need? We need time varying electric or magnetic field. Now we have seen that charge produces electric field, which is constant. Current produces magnetic field, which is again constant if the current is not varying. But we need a varying, time varying electric field or time varying magnetic field. Only time varying electric field will produce the time varying magnetic field, and they will sustain each other. Otherwise there will be only one field. So how can we produce it? It can be produced by accelerated charges. Accelerated charges produce EM waves, not stationary charges, nor the charges moving with constant speed. We need accelerated charges. And these waves, Maxwell did his work in 1865. In 1887, Hertz produced these waves. There's another very important Indian scientist, J.C. Gauss. He produced in around this. And then Marconi produced in around 96. These were the radio waves. He made first real life application of these waves. Right? These two were produced in the lab. But this radio waves, so they traveled along English Channel. So large distance was covered by the waves produced by Marconi. Hertz experiment, I can give you a brief idea of it. We need accelerated charge, keep in mind that thing. So these are the two metallic balls connected to two metallic plates, and this is connected to an induction coil. The purpose is to produce alternating actually charges on this. So this gets positively charged, then this is minus, then this is minus, this is plus, and it is not constant. So it acts just like a dipole. But dipole with changing dipole moment. So if I take this point, we have an electric field produced by it, but that field is not constant. That is a time varying. And we know time varying electric field produces time varying magnetic field. And time varying magnetic field in itself again produces time varying. So once we produce it, these time varying electric and magnetic field, they will be produced. Each one will produce the other. They will sustain and move. This energy will propagate in space with a speed of 3 into 10 raised to power 8. So that is much higher. So in seconds it will be able to cover the entire Earth. 3 into 10 raised to power 8 meters in just 1 second. So, and how did he detect? This was a detector again, 2 electrodes and B separated by just air gap. And if the electric field is produced here, there should be some spark between the two, and he observed this spark, which means the electromagnetic waves are actually produced. I am not giving you the actual dimensions related to all this, that's not needed. The idea is that you need an accelerated charge to produce. And the simplest I can tell you, accelerated charge means you take a comb, rub it on your hair, it is charged part, it is charged now. Now if you keep on moving the comb like this, even this is the source of electromagnetic waves then. You take a balloon and then move it after rubbing on your hair. So this is also a source of electromagnetic waves. You need an accelerated charge and it should move it should accelerate, it should have an accelerated motion. So a body making simple harmonic motion, it will have a definite frequency. The electromagnetic waves produced will have a definite frequency. Okay, now, nowadays, we have the waves which have wavelength as small as 30 femtometer and maybe as large as about 30 kilometers. This is the range of the electromagnetic waves that we are producing and using. As far as the properties of EM waves are concerned, so we all are aware of the properties of light. They are reflected, diffracted, they show interference, they exert pressure on the surface on which they fall, and they carry electromagnetic energy. That expression I can tell you, energy density. This is half epsilon naught E RMS square. Energy density means energy per unit volume, or in terms of peak value, it is E naught square by 2. E RMS is E naught by 2. So it becomes, and for magnetic field, or it will come out to be B naught square by 4 mu naught. So this is the density, energy density for magnetic field. This is for the electric field, and if we we know the relationship between E naught and B naught. We can see that average energy density is equal in electric field as well as in magnetic field. They both are come out to be same. Okay, and then let me arrange some electromagnetic waves that we use. Radio waves, microwaves, infrared, visible, UV, X-rays and gamma rays. This is increasing frequency and decreasing wavelength. So wavelength is maximum for these. Radio waves are used for communication purpose. Microwaves are also used for communication. Higher frequency range. For TV transmission we use microwaves, and these are used in microwave ovens. Infrared, mostly in remote control devices we use infrared radiation. They are also used for medical purpose. Heat radiations they are actually. Visible, we all know it is light. UV radiation mostly used for sterilization purpose. They are though dangerous, but even then we use them for killing harmful bacteria. Food preservation and sterilization we use UV rays. X-rays for the diagnosis of bone fracture, and gamma rays are specifically used for treating the tumors. There are many other applications of all these waves. You can research and you can view various books and sources to find out many other uses of these radiations. And you should also be aware about the frequency range of all these. Visible, we all know about 360 to about 800 nanometer nearly. Actually there is no sharply defined boundary. There is always overlapping. So radio waves, this is X-rays are about 1 angstrom order. wavelength, and same way you should have an idea what is the range of the wavelength. No need to learn specific numbers or the values, but you should have an idea what is the use of all these radiations and what is the approximate wavelength or frequency. If you know anyone, you can find out that all move with the same speed, 3 into 10 raised to power 8 in vacuum. So that's all. I'm giving you a list of the wavelengths of all these radiations and different uses also. You can read from here, just go through this sequence that I am giving you. Spectrum means an arrangement of the radiation in a specific order. This arrangement is not random. So increasing frequency, decreasing frequency, increasing wavelength, decreasing, you can take any. But the sequence should be logical. Okay, that's all in this topic. Thank you.